All right, now we're going to take a look at example 3. Find the missing terms in the arithmetic sequence. So the really nice thing about this lesson is that there really is a variety of ways you can approach these problems and still get the same results in the end, still get the same answer. So know that if you're really not understanding or liking the method I use to go through an example problem, you're always welcome to reach out to me or to do some research on your own to figure out another method to approach these problems, because there really is a variety of ways to approach them and still get the same answer in the end. Okay, so we want to find the missing term. We know that it's an arithmetic sequence. We know this already. It's given to us. It says arithmetic. What that means is I have a common difference. I have this constant number that I'm adding or subtracting each time to get from my starting number of 17, and I'm going to add or subtract that same number 3 times to then get to -7. So you could use that and do a little bit of trial and error in how you can figure that out, and that's perfectly fine. I have a lot of students that do that with success on these types of problems. If you want a method that's maybe a little bit more formal and a little bit more of a process versus some guess and check, then that's what I'm going to walk through you with next. So we know it's arithmetic, so I know it's going to fit the mold of being able to write an explicit rule looking like this. And this is that general rule we defined for ourselves earlier in this lesson. A sub n equals a sub 1 plus n minus 1 times d. Now, I know a sub 1, it's given to me in the problem. A sub 1 is always your first number in the sequence. So I know a sub 1 is 17. I don't know n because I am, that's just a variable in there. We don't have n specifically defined. The problem doesn't say define a specific term number, so we don't have n exactly. And we don't have d. So we're in a bit of a dilemma here, because in order to use this formula, we need to know n, or we need to know the common difference d. So what we can do is we can use the information that we have. So even though the problem's not set up like example 2 where it says find the 11th term, we do have another term number that we're given. So a sub 1 we're given is 17, a sub 2 we don't know, a sub 3 we don't know, a sub 4 we don't know, but a sub 5 we do know. Meaning I know that whenever I plug 5 in for n, it needs to give me -7 in this formula I have written at the top of the screen. So I'm going to use that to my advantage. So I'm going to say, well, a sub 5 equals a sub 1, which I know is 17, plus my value of n here that I've plugged in is 5. It's the 5th term, minus 1. And I still don't know what that common difference is, so I'm going to leave it as a d. You might be wondering, well, where's this going? Because right now we still have a lot of variables and there's not much we can do. Well, we need to remind ourselves that we know a sub 5's value. We know what a sub 5 is equal to. It's equal to -7. So we can plug -7 in and be left with -7 equals 17 plus 4 times d. And I got 4 because I subtracted 1 from 5. Okay, so I did that math there. So I plugged in my value for the 5th term. I plugged in 5 for n, and this is what I'm left with. -7 equals 17 plus 4 times d. Now I can solve for d. I can subtract 17 over, giving me -24 equals 4d, and I can divide by 4, giving me -6 is equal to d, which means to get from one term to the next, I'm subtracting 6 every time. So, oops, sorry about that. So, when I know that we're starting with a value of 17, I need to subtract 6 from 17 to take me to 11. Then I need to subtract 6 again to take me to 5. Then I need to subtract 6 again to take me to -1. And then to kind of verify that this does work, if I subtract 6 again, does it take me to -7? And the answer would be yes, yes it does. All right, let's go through another one of these. So example 4, find the missing terms. I recommend pausing the video and seeing if you can do this on your own. Then press play to see the answer. Going through this process, again, and I want to stay consistent with what I did in the last one in case any of you really like that method. But if there's another way you want to go about it, that's totally fine by me. You do not have to have your work looking the exact same as mine. Okay, because some of us just approach problems differently, and that's okay. So I'm going to use the general formula for an arithmetic sequence. A sub n equals a sub 1 plus n minus 1 times d. I know a sub 1 is 2. I don't know what a sub 2 is. I don't know what a sub 3 is. And I don't know what a sub 4 is. But I know a sub 5, my fifth term, is 0. So I'm going to use a sub 5, and I'm going to use a sub 1, which has a value of 2. I'm going to plug 5 in for n, and I don't know what d is, so it's going to stay the same. I know the value of a sub 5 is 0. So I'm left with 0 equals 2 plus 4d. From here, solving for d, I'm going to subtract 2. Giving me negative 2 equals 4d, divide by 4, and I'm getting negative 1/2 or negative 0.5 is equal to d, which means to get from one number to the next, I'm going to be decreasing by 1/2 every time. So if I subtract 0.5 from 2, I'm left with 1.5. Minus 0.5 again, I get 1. Minus 0.5 again, I get 0.5. And minus 0.5 again, I'm left with the value I know of, which is 0. So it just proves to me that it does work. Again, you could have figured this out by doing some trial and error or maybe applying some past knowledge of slope, and that would have also worked. You did not have to go about this problem the exact same way I did to get the final answer. All right, let's move on to example 5. So example 5, it says find the fifth term of the arithmetic sequence with a sub 8 equaling 85 and a sub 14 equaling 157. Now, you could use a very similar process you did on examples 3 and 4. It's just that this time around, it might be a little bit more challenging because there's a bigger gap between the two terms that were given. So let me kind of write some things out to maybe give you a visual of what's happening here. So what we're looking for is a sub 5. A sub 5 is what we want. We don't know what a sub 6 is. We don't know what a sub 7 is, but we do know a sub 8. The 8th number in our list is 85. We don't know what the 9th, 10th, 11th, 12th, 13th numbers are, but we do know the 14th number is 157. So the two values we have are written, and the one we're looking for is there. Now, thinking logically, notice that going from the 8th number in this list, 85, to the 14th number, 157, our values are getting bigger. So we know that we're increasing going from one number to the next. What that means for us is that when I'm looking for my fifth term, I should end up with an answer that's smaller than 85. And if I don't, then I would need to go back and check my work, because as I'm going from the front of my list from the first term all the way up to now looking at the 14th term that we have written down, my numbers are getting larger. There's a variety of ways you can go about doing this. You can use a similar method that you did on examples 3 and 4 if you applied slope or did a little bit of guess and check to figure out what that common difference is, and then you can just subtract that number backwards from the 8th term, taking you to the 5th term, and that would be a very appropriate method. If you want to stay consistent with what we did in the last two problems, using that general formula for an arithmetic sequence, which I'm writing down right now, that's what I'm going to go through next. Okay, so I'm going to use that to help find my answer here. I'm going to use it because when applying this formula, there's a couple things that stay consistent. N still needs to be N. We know that whatever the subscript is on the left side of the equal sign needs to be the same number we're plugging in for N on the right side. We've been using that all throughout this lesson. One thing that we've not talked about is that a sub 1 here has a subscript of 1. It's referring to the first number in our list. Well, we don't know what the first number is, but we subtract 1 from N because we plug in the first term here. So this minus 1 is only a minus 1 because the subscript of that number is 1 on the right side of the equal sign. What that means is we can alter this to meet the needs of the numbers and the terms that we have. So we have the 14th in the 8th term. So I can say a sub 14 equals a sub 8 plus, and now this subscript is a 14 on the left side, so I have to have 14 here. My subscript on the right side, this is an 8, which means I need to then subtract 8 here. Those subscript and the big number that you're subtracting needs to stay consistent. So normally the general formula is a sub 1 and we subtract 1 inside the parentheses because we're usually given the first term. But if you're not given the first term, you can change that. You have the power and the abilities to do that. It just means that the number you subtract in the parentheses is going to change to whatever term value you're referring to in that subscript, which is pretty neat. Now we can plug in our actual values. So a sub 14, the value of the 14th term is 157. A sub 8, the value of the 8th term is 85. And 14 minus 8 here is going to take me to 6. Now we need to do a little bit of algebra to solve for D. So I'm going to subtract the 85, giving me 72 equals 6D, dividing by 6, giving me 12 is equal to D. And then from there, I can just subtract 12 until I get to the 5th term. Another way, instead of subtracting 12 backwards to figure out what the 5th term is, another method you could use is you could use this formula that we had kind of already set up for ourselves here. We're now looking for the 5th term, so a sub 5. That means the number I'm plugging in for N is going to be 5. I still don't know what a sub 1 is, but we've already set this up with a sub 8. So I can write this as 85 plus 5 minus 8, and then times 12. So I can still use a sub 8 and then minus 8 here, since I don't know what the first term is in that general form of an arithmetic sequence that I have written at the top of the slide. From here, doing a little bit of math, we would have 85 plus, and then that would be a negative 3 times 12. So that would be 85 plus negative 36. And that gives us 49. So that means my 5th term is a value of 49. Now again, you did not have to go through and find the 5th term the way I did. You could have just gone through and subtracted 12 3 times to work your way backwards, and you would have gotten to 49 just the same.